Hello, everybody. Welcome to the first of two lessons in a row on evaluating functions. This will be the second and third lessons of our functions unit. So let's just go right ahead and dive in. Hit attempt quiz now, and you should be seeing a problem that looks very much like my number one. These first four problems, we're going to have basically the same exact problem. And I'm going to teach you, or in some cases remind you if you already know it, what a independent and a dependent variable are, because each function has both an independent variable and a dependent variable. Here's the way I like to think of this. With a dependent and independent variable, one variable depends on the other directly. So then I like to ask myself with these word problems, like the first one we have the weight of apples in pounds and the total cost. So I say to myself, does the weight of the apples in pounds depend on the total cost? Or I go backwards, does the total cost depend on the weight of the apples? Now it would be interesting if you could change the weight of an apple in front of you by just like pulling out more money somehow, but that's not how it works. Therefore, it's backwards. And notice what I do. I start with the bottom first, the dependent variable. And I basically say the sentence as I fill it in. The total cost of the apples depends on the weight of all the apples. And then I fill it in like that. So it almost forms, you could think of this like a little, it's like a counter, so it's like a clockwise little rotation where I start at the bottom here and then I go up and around. Always start at the bottom. So I'm going to do the same thing on the next one. Ask yourself, does the number of popsicles eaten depend on the temperature outside in the summer? Or does the temperature outside in the summer depend on the number of popsicles eaten? Can you imagine if it was the summertime and you're like, oh, I really want it to be cooler outside. It's too hot. And so you just start stuffing your face full of popsicles and you get like 10 in and you're like, oh, I have a brain freeze now, but at least it's 10 degrees cooler outside. That'd be a very interesting superpower that I don't think anyone's ever said would be their preferred superpower of all of them. So it's not that. Instead, it's that the number of popsicles eaten depends on the temperature outside in the summer. Generally, the hotter it is, the more people want popsicles because they're dehydrated. They want the popsicle goodness at that point. Maybe you get Otter Pops from Costco, whatever you get. Not to say you don't like necessarily want a Otter Pop or a popsicle if it's colder, but largely, like say it's really cold, it's a blizzard, you normally want like hot cocoa then. Of course, I'm one of those people. I like ice cream all the time. Tillamook Mudslide represent. All right. Number 3, does the number of hours worked depend on the amount of the paycheck? Or does the amount of the paycheck depend on the number of hours worked? Pause your video and see if you can figure it out, but don't hit check, and then I can check your work for you before you hit check. Hopefully that gave you enough time to pause it. Well, some people get paid before they work, kind of like a kind of credit system or some sort of collateral, but most people generally get paid afterwards. And the amount of their paycheck, notice again, I'm starting from the bottom and doing that cycle up top. The amount of the paycheck depends on the number of hours worked. You get paid after the fact. All right, number 4, pause this too and try this one if you haven't already. A person's total weight loss and the number of miles he ran. This one's a little counterintuitive because you think, well, if I lose a bunch of weight, I'm sure I could run farther, but that's not always true. You could be like really sick, for instance, and be home for 2 weeks, lose 20 pounds, and then you're not going to be able to run at all. You're incredibly weak still. So instead, this is about burning calories, trying to burn more calories than you consume. There are many fad diets out there who try and convince people that they could eat whatever they want and do whatever they want, and they're just going to lose weight no matter what. Sorry, it's actually a mathematical problem, an equation where if you burn more calories than you consume over time, most people will lose weight. There are still exceptions of health specifics that people can have, but in general, you try and burn more calories than you consume. So, hopefully you had that a person's total weight loss, or in this case, his total weight loss, depended on the number of miles he ran. In that order from bottom to top. Okay. Cool. Now we're going to have 4 problems. We just had 4 word problems. We're going to have 4 problems where we evaluate functions, meaning we simply just plug in a value for x. You know these are a function in terms of x because it says f parentheses x. That means plug in whatever you want for x into the right side of the equation, and the function will spit out a value, f of x, that the whole equation equals. So how to figure that out manually, pull up your Desmos calculator if you haven't already. Pause the video if you need time. And then you're just going to type your right side. So I've got a half. I can hit 1 and then slash on that right side of my keyboard. If you don't know where that is or are confused, you can also just hit the division sign here. And then I press the right arrow key to get out of the bottom of the fraction. And then parentheses, I have some number. For me, it's 4. For you, it's probably some other number. And then complete the rest of it. So I've got 1/2, 4, and then I have a minus 4. So minus 4. If you do that correctly, it's going to spit out a number. That's your function number that gets put out as your output. You plug in 4, you get out -2. The same thing on the next one. Now I've got 4x squared, where instead of x, I'm going to plug in 4. I've got 4 I'm plugging in for both of these. Lots of 4s in my problems. And then I need to square this because it's 4x squared, so I can either hit this squared button here, or I can do Shift 6 and a 2. And that tells me 64 is my answer. Okay. 2 more like this, and then we're going to do a couple of algebra challenge problems here. I'm plugging in -12. Notice this looks a lot like my first one. There's a fraction, there's some subtraction. So I'm just going to, instead of typing out all this again, I'm going to be smarter than that. I'm just going to cover up this and replace some of the numbers. So instead of 1/2, I'm going to come up here and make this 1/4. And instead of plugging in 4, I'm plugging in now -12. And then bam, just a few clicks, and I figure out it's -7. Smarter, not harder. That's a good strategy to try and work. Oh! Did I plug in the wrong number? 1/4. Oh, I forgot to change the -4 to a -7. Drat. Okay. Well, don't make the same mistake I did. But again, think smarter, not harder. 1/4 now, -16, -2. Even though I had to redo it, it's going to take, 10 seconds total? Because I can just fill in, this time correctly, my old equation. Same thing with 8. I've got some amount of x squareds again, so I could change it to 8x squared. And then -10 for x. And I can hit check before it does anything, so it's not going to even allow me to do it. Oh, man. There we go. You rock. Thank you. Appreciate that positive affirmation after making several mistakes just now. All right, 9 and 10. Okay, let's clear the calculator. Go grab something to write with and write on if you don't already have it. Now, if you just want to sort of give up and get an 80% at this point, I don't recommend that, but you always could get that B-. Or you can go for the A, and you can do these challenge algebra problems where we once again use backwards PEMDAS, and we don't have any parentheses, so we're going to call it the same thing we always call it in class. Instead of sad MEP, it's sad me. Sad me. So sad. This is my favorite algebra acronym because it involves subtraction and addition, division and multiplication, and finally exponents in that order to complete our algebra problem. So for this, here's how we set it up. P of x is -59. So I'm just going to start by writing that down. If you have a piece of paper, you can write that down, whatever your P of x equals. And then your right side, you just transfer over. So my right side is -6x plus 1. So I transfer it over and write -6x plus 1. So I have 2 rules when I'm doing algebra. I have sad me, and I also have this line that goes straight down the middle of my equal sign that I always do on algebra problems. Because you need to treat both sides of this equal sign like 2 kids that you make sure you're feeding equally, you're giving everything to equally. Because just like my mom did for my triplet brothers and I growing up, if there was ever even one goldfish given to one brother but not the other, there would be an all-out war. And we're very much trying to prevent wars here in math land here. So both sides equally, and then we need to follow the directions of SADB. So step 1 is subtraction and add. So I can do the opposite of what's happening in my equation. I look for adding and subtracting. In this case, I have adding. And I think about what's the opposite of plusing 1? Well, it's minusing 1. So I need to minus 1 from both sides. Notice I'm using red to distinguish between my old numbers. That gives me 58, and I still have negative 6x. Okay, now I have the next step. What is happening here between this negative 6 and this x? Ooh, it's that weird thing that sometimes I say, which is if you have a number and a letter and they're touching, there's no plus sign, there's no minus sign between. It's like two rabbits that you leave together. They multiply. We need to do the opposite, not kill the rabbits. We need to divide. So this next step I'll use for green. Divide by negative 6. Okay, oh my gosh though. Did you see the mistake that I made today? Look up here. Negative 59 minus 1 is not 58. 59 minus 1 is 58, but negative 59 minus 1 is actually negative 60. And I knew I had made a mistake because I knew that it wouldn't divide evenly. And this problem should always divide evenly. You should not get any decimals. So if you're like me and you do this division step and you get a decimal, go back, check your work, you've just made a mistake. Instead, I've got this lovely Christmas color right here. Negative 60 divided by negative 6 is 10. X is 10. So this is one reason that I wish we still were in class with our graphing calculators so I can have up the smartboard lesson and then separately the graphing calculator, and I wouldn't have to do this thing where I couldn't use my calculator when I'm writing on my screen. But first world problems, I'm still more than grateful for having the ability to write on the screen, record the video, and do the calculator. Please, please, please let that work. This is a problem I would not like to have to redo in front of everyone. Yes. And sure enough, I could actually check this if I plugged in 10, my answer, just like we did for the previous 4 problems. And I plug it in correctly. You'll see negative 59 matches the negative 59 I was supposed to get. And that's kind of a fun thing to do too. So for number 10, you can do the same thing, which is write out your problem. So I write out 10 equals x over 5 minus 3. And then I go through my SADME, I add 3 to both sides, and then I do the opposite of dividing by 5, which is both by 5. Or, check it out, sometimes people like to do the old guess and check method. So I'm just going to write out my right side, including x over 5 minus 3. There is some number, minus 3, some number that I could plug in for x, that if I divide it by 5 and then subtract 3, I know I'll get 10. And if you're ever on a test or something, and this is just like giving you so much anxiety, and you think, I have no idea how in the world to do this. I know something about SADME, but I forget. You can always just plug in. This is one of the great things about algebra. You can plug in any value and just sort of guess and adjust until you figure it out. So I'm going to throw out numbers that are divisible by 5. So either it has to end in a 5 and a 0. So like, 50. And I get 7. Well, I don't want 7. I want 10. So let me keep going up by 5. 55. Ooh. Can you see the pattern? 60. Oh, 65. Yay. When it equals 10, I know I've got my answer. So I have shown you successfully now the 2 ways of doing these problems. You can write them out, do some algebra, use some SADME, or you can do some nice old-fashioned guess and adjust. And just sort of play around with your calculator and see what answer ends up giving you the correct response. Okay, there you go. The second assignment will be the next lesson that we do. It's going to be very similar. There's going to be some word problems, even maybe some of the same ones to see if you remember how to do it. Then some evaluating functions, the first way where you're just plugging it in, and then the backwards where you're either guessing and adjusting or doing algebra. I like giving you a lot of practice on this because it's pretty useful. All right. As always, I hope this video finds you safe, happy, healthy, and well. This has been Virtual Class Away from Class. Much love to you all, and best wishes on your day.